We have discussed the concept of association in the last class, and we have discussed some properties of association in the last class. Now we will use this concept for getting bounds for the system reliability on binary system. Okay, the first result is, you can see that if x1, x2, x3, xn are associated binary random variables, then probability of product I from 1 to n xi equal to 1 greater than or equal to product I from 1 to n probability of xi equal to 1. And the second result is probability of union I from 1 to n xi equal to 1 less than or equal to union I from 1 to n probability of xi equal to 1. Okay, so let us prove the result. I will prove the first result and you have to prove the second result as using the similar step. So, you know, what is the what are the properties of association? You know, if x and y are associated, then the non-decreasing function of that x and y will be also associated. So we will use that property. Here we have x1 and product I from 2 to n xi. You know that x1, x2, x3, xn are associated random variables. Surely x1 and the remaining product of the remaining variables, that is I from 2 to n xi. So this is the increasing function of x2, x3, x3, xn. So x1 and this product are increasing functions of x1, x2, x3, xn. So naturally, by using the property of association, these two variables, that means x1 comma product I from 2 to n xi, are associated. Okay, so if these two variables are associated, then what is the definition of association? What is the definition of association for these variables? We can say that covariance of x1 comma this product is greater than or equal to 0, right? This is greater than or equal to 0. So this is using the concept of association. Okay. Anjana Krishna.
Present, sir.
Kavya.
Present, sir.
Amal John. Rahul PM. Lindsay Aloysius. Gogul Raj. Nigel. Anju PS. Fahima. Estina. Alvin. John NJ. Aloysia. Jewel Paul, Stephen, Ajay Krishnan, Sindamol,
Present, sir.
Ajay ഉണ്ട്. Sindamol,
Sir. Present, sir.
ഞാൻ
Present, sir.
എടുക്കാത്തത് അറ്റൻഡൻസിൻ്റെ പോർട്ടൽ നമ്മുടെ കയ്യിൽ ഓപ്പൺ ആയിരുന്നില്ല, അതുകൊണ്ടാണ്. ഇനി മുതൽ എല്ലാ ദിവസവും ഞാൻ അറ്റൻഡൻസ് എടുക്കും. ഇതിൽ ആരെങ്കിലും ഇനി പ്രസൻറ്റ് ഉണ്ടോ നോക്കിയപ്പോൾ? ഉണ്ടോ? ആരത്? ഫഹീമ. വേറെ ആരെങ്കിലും ഉണ്ടോ? കൺഫേം ചെയ്യാം കേട്ടോ. Okay, so so this is the definition of association. But you know that what is covariance? You know what is covariance? What is covariance? Covariance is nothing but expectation of the product of the function minus expectation of x1 into expectation of product xi. Okay, so this is the expectation. Covariance x comma y equal to expectation of x into y minus expectation of x into expectation of y. So that idea is applied here. So you can see that this is the answer. But you know that this is actually, this is nothing but this is actually what is that? Instead of x1 into x2 into etc., we can write product I from 1 to n xi. Okay. Okay, so this is the simplified form. So you can again simplify this one. What will be the answer? Yeah, greater than or equal to comes here. Okay. Okay, so this is the formula. Okay, you can call it as equation number 1. And we can iteratively apply same formula for the so instead of this one we can write another formula. That means this will be greater than or equal to, using equation number 1. Using equation number 1, this can be called as 2. Using equation number 1, we can say expectation of product I from 2 to n xi is greater than or equal to we can apply similar formula. Okay, what will be the answer? If you take I from 2 to n, what will be the answer? It will be just x2 into from 3 to n. So this is an iterative formula. This idea can be applied to this formula. Okay, so this will be we can denote it as equation number 3. So now we can put this function instead of this expectation product, we can put this one. So what happens? So equation number 2 will be this we can call 2, and this will be case number 3. Okay, so this will be the so 2 in 1, right? 2 in 1 gives this equation. Again we can substitute, instead of this one we can substitute similar formula as in the case of equation number 2. So we will get, what will be the next step? What will be the next step? Okay, expectation of x3 into from 4 to, okay, equation number 4 and etc. We can apply this formula to the entire up to n, I equal to n. So what will be the result? Into etc. This will be I from n to n. So that is actually, okay, this is nth formula. Just okay, that's it. So instead of this one we can write okay, so this is the last formula. This we can again simplify because this is a binary system. So binary system will have, this is a structure function of series system. This product I from 1 to n xi is the structure function of series system. So expectation will be probability of product xi equal to 1 plus 0 into probability of, so instead of expectation we can write it as probability of this one equal to 1. Okay, and similarly here also we can write this is as probability of xi equal to 1. So this is the formula given in this book. Where is it? Yeah, this is the formula, equation number 3.1. Probability of product I from 1 to n xi equal to 1 greater than or equal to product I from 1 to n x, probability of x1 equal to 1. Okay, now we can take the expectation of union. What is the expectation of union? Expectation of union I equal to 1 to n xi. Okay, that is exactly equal to expectation of 1 minus product, right? I equal to 1 to n this is 1 minus x. Okay, so we can ഹലോ,
സാർ ഭയങ്കര ഡിസ്റ്റർബൻസ്, അതായത് ബാക്ക്ഗ്രൗണ്ടിൽ പാട്ട് ക്ലിയർ ആവുന്നില്ല, ഭയങ്കര
കേൾക്കുന്നില്ല?
പച്ച.
കേൾക്കുന്നില്ലേ?
അല്ല സാർ, കേൾക്കുന്നുണ്ട്, പക്ഷെ ഭയങ്കര ക്ലിയർ ആവുന്നില്ല.
ഇപ്പൊ കേൾക്കുന്നില്ലേ? ഇപ്പൊ ക്ലിയർ അല്ലേ?
Yes, sir.
So this is equal to uh, 1 minus I from 1 to n aspiration of 1 minus x. This can be written as probability of equal to 1. Okay. So we can write the first and last time. You know that product, we can take the we can consider this function only. So what will be the okay, expectation of union I from 1 to n xi equal to expectation of 1 minus product I from 1 to 1 minus xi, that equal to 1 minus product I from expectation of 1 minus xi, that equal to 1 minus product I from 1 to n, 1 minus expectation of xi, that equal to 1 minus product I from 1 to n. Okay, but you know that this should be less than or equal to, because in the case of product, you know that product PI, that means this we can write like this. So what is this actually? This is actually okay, we can write again. Probability of what's that? union y equal to 1 to n xi equal to 1. That is actually the expectation value. So expectation union xi equal to probability of union xi equal to 1. That is actually equal to what we have obtained. One minus okay, we can take this. But you know that x1, if x1, x2, xn are associated, then 1 minus x1, 1 minus x2, etc. 1 minus xn are associated. Okay. You have to use the result that if x1 comma x2 comma etc. xn are associated. Wait down. ആരത് മറ്റേ എൻ്റെ ബാഗിലുണ്ട് കേട്ടോ. എൻ്റെ ഉള്ളിലുണ്ട് പെട്ടിക്കത്. എൻ്റെ ബാഗിലുണ്ട് ക്വസ്റ്റ്യൻ. If x1 xn are associated, then 1 minus x1 comma etc. 1 minus xn are associated. Okay. So what will be the formula for 1 minus x1, 1 minus x2, x2, 1 minus xn? Using the previous result, we can say that expectation of what is that? So you can take the product I equal to 1 to n expectation of അല്ല അതിൻ്റെ തന്നെ എൻ്റെ ബാഗിലുണ്ട് 1 minus xi. Okay, that will be less than or equal to product xi equal to 1 less than or equal to from 1 to n one minus xi. Okay, so automatically what happens? Multiply both sides with -1, so this will become greater than or equal to. When we multiply, that will become greater than or equal to, and then okay, and then add 1 on both sides. So 1 minus this will be greater than or equal. Okay, so what will be the result? This is actually what is that? We can apply this equation to this formula. this formula. Okay, this expectation of xi will be greater than or equal to expectation of xi will be greater than or equal to this. Here we can take the expectation outside. Here we can take the expectation outside. Okay. Outside. Here we can take expectation inside. What will be the result? Okay. So this is exactly union expectation of xi. Union equal to 1 to n expectation of xi, and this is exactly expectation of right.
So thank you.
Okay, so what we have obtained? What is the result? Again we can simplify further. We can remove this term, just use the no need to use this term. We can remove this term. Okay, so at last we obtain. It is not 1 n, is n. Sorry, n 1 to n. N is here. I think you got the step now. Now we can apply probability. What will be the result? Equal to 1. This is probability of so that is the second result. This is the second 3.2. So we have proved both results, 3.1 and 3.2. I will send these formulas to your WhatsApp group. So this is a fundamental formula using for further calculation of bounds for the reliability. We will apply this formula to the So we will have different results, so that will be discussed in the next class, no problem. Anyway, you study this theorem and its proof today and submit in the Moodle platform. Okay. Leaders, ബാക്കിയുള്ളവരൊക്കെ എവിടെ പോയി? റോസ്മിൻ.
sir.